So you have some questions in your homework about converting between decimals and fractions. And the book does give you an explanation of one method to do this, but I want to show you a shortcut for repeating decimals and converting those to fractions, okay? And to start this, I want you to think about a couple of things. So there are some fractions and repeating decimals that we're already familiar with, all right? So for example, 1/3, we know this to be 0.3 repeating, okay? And then also 2/3, we know this to be 0.6 repeating, okay? Those are some common ones, but looking at this a little more closely, 1/3 is also the same thing as 3/9, right? Basically, I'm just unreducing that fraction. And then 2/3 is the same thing as 6/9. Okay, so just based on these two right here, it might be enough to have an observation that 0.3 repeating is the same thing as 3/9, and 0.6 repeating is the same thing as 6/9. Therefore, any digit that's repeating might be that numerator over 9, okay? And actually, this does turn out to be true. And you can, try it on a calculator if you want, if you don't believe me. But what we find is that 4/9 is equal to 0.4 repeating, 1/9 is equal to 0.1 repeating, etc. And so anytime you have a decimal that is repeating and it's a single digit, you can put it over 9 and change it to a fraction. So that would be a shortcut. If I want to know what is 0.8 repeating, okay, as a decimal, I can quickly say that's going to be 8/9. All right. Now I will also pause for a second on that and say that this does lead us to a very interesting discussion about 0.9 repeating and whether or not this is equal to 1. Okay? And that's something that I would love for you guys to take a minute and think about, or take a few minutes. Take lots of minutes. Sleep on it. Tell me what you come up with. Okay? It's a source of a lot of arguments, but it's a good thing to think about, and I wish that we could have that conversation in person right now. All right, so back to the converting decimals. Now, let's say that we don't have just a single digit repeating. Let's say that we have a 2-digit number that repeats, so maybe 0.41 repeating, okay? We could go through the process in the book for converting this, or I am totally fine with you using this shortcut. This is 41/99. Because I have 2 digits that are repeating, I put it over 2 9s. Okay? Or if I have another one, let's say we have 275 and all of that is repeating, or yeah, sorry, 0.275 repeating, I can write that as 275, not 9, over 3 9s because there's 3 digits that repeat. Now, one thing that you do need to pay attention to, though, is if this fraction can be reduced, you should reduce it. Now, this can't be reduced, this one can't be reduced. I intentionally picked ones that can't be reduced, but if we had something like 0.120 repeating, okay, 120, 120, etc., well, 120 over 999, that's definitely divisible by 3, so we can write this as 40 over 333. So if you can reduce, then you do need to do that. Okay? All right, next question. What if the number that, or the digits that start repeating are not right up against the decimal place? Okay, maybe there's something else in front of that. So my suggestion here is to split any number into 2 pieces, the non-repeating part and the repeating part, and then write them both as fractions and add them together. Okay? So for example, let's say we have 2.57 and only the 7 repeats, so 2.577777, etc. Okay, I'm going to write this as 2.5 plus 0.07 repeating. Okay, and then once you get the hang of this, you don't need to do these in between steps, but this is just for explanation purposes. All right, so I can write this as, well, 2.5, I know that's 25 over 10. Okay. And don't worry about reducing it because we need to add things together first. Okay, so 25 over 10. And then this right here is 1/10 times 0.7 repeating. Okay, because multiplying by 1/10 makes the decimal move to the left one. Okay, so I have 1/10 times 0.7 repeating, or in other words, 25 over 10 plus 1/10 times 7/9. Okay, so now we're looking at 25 over 10 plus 7/90, and now I just need a common denominator so that I can add these two together. All right, so remembering our fraction skills from, third or fourth grade, we're going to multiply this by 9/9. 10 times 25 would be 250, so let's take one of those away. So we've got 225 plus 7/90, 90, which is going to be equal to 232/90. Okay, now in this case we do need to reduce. Both of these are even numbers, so let's cut that in half. Okay, so 45 in the bottom, and we're going to have 116/45. All right, so that one took a little bit more mental math at the end, but it still is probably going to be faster than going through the process in the book. Let me know if you have any questions over that.